Hello and welcome back to Refrigerator YouTube videos, and welcome to Puttin' in Bay, where Puttin' in Bay is the putamen, and it's all about the motion of the ocean in this Refrigerator YouTube video because we're talking about movement. And so, let's begin. Alright, so we're going to look at three key ideas in this, and we're not talking about any circuits here. We're just going to talk about three overarching ideas, and I believe if you have these set in stone, they'll really be able to help you understand the basal ganglia and be able to score high on the questions. And with my research I did in undergrad, this is kind of where I began with the basal ganglia, and I believe it just opened new windows and doors for me to really see the light of how beautiful this system can be. Alright, so let's begin. Point number one is the thalamus excites movement. And notice when I say excites movement, we're only talking about a movement here. We're not talking about neurotransmitters. We're not talking about excitation or inhibition at the neurotransmitter level. We are just talking in general about what excites movement. So if the thalamus could have his way, he would always excite movement. That's all the thalamus wants to do. And that's why it's here in green. Also, if you look here at the thalamus, I underlined the M to help remind us that it's all about movement. So if the thalamus could have his way, he'd always be having us move. All right, now let's hop down here to point number two. The globus pallidus the internal globus pallidus, it always wants to inhibit movement. And look at this. This is beautiful because it's right here. There's your eye. There's your eye and inhibit. Boom, bada bang. We're going over here. We're inhibiting movement. And how do we do that? We go up here and we inhibit the thalamus. If you have those two keys down, it'll be able to understand the whole direct and indirect pathway. Okay, so stepping back, let's go down here to point number three. Puttin' in Bay. It's actually it's a body of water up in Cleveland somewhere, I believe. And I just thought about it, the movement of the ocean, Puttin' in Bay, it just sounded like putamen to me. And the putamen, where do you put in your boat? You put it in the bay. And the putamen is where all the input starts. If you want to start anywhere with the basal ganglia, start at the putamen. It's getting all the input, okay? Starting there. Okay, and that's why I labeled it 3, to remind us that there are actually 3 receptors on putamen cells. Now I know we talked about D1, D2, we'll get all of that when we go into the direct and indirect pathway, but I like to think of the putamen as having 3 receptors on them. And the first of those receptors, and it's in those putamen cells, in the striatum, the putamen, and in those cells, there's 3 receptors on each cell. There's a dopamine receptor, an acetylcholine receptor, and a glutamate receptor. Okay, let's start with dopamine. Well, look, it is labeled in green. So what does that mean? Dopamine is the fuel that we need for our boat in Puttin' in Bay. Without dopamine, there is no movement, there is no fuel. It is like, if you're driving a car, you'd be like, duh, we need fuel. D-A, duh, duh. Gotta have fuel to get your boat going. Dopamine always helps us get to movement, whether it's the direct or indirect pathway. Start there. Dopamine gets movement. All right, now we're going to move over to acetylcholine. And I should mention with dopamine, it's all coming from that substantia nigra pars compacta. That's our source. That's the gas station. The substantia nigra pars compacta is the gas station. Dopamine is the fuel. All right, now let's hop over here to acetylcholine. Well, it's in red because it has antagonistic effects compared to dopamine on motor. On motor, just keep motor in mind. It is inhibitory to movement in motor. And what I like to think of with this is like if you're driving a boat or driving a car, there's always that acetylcholine in front of you that's making you late. You get my drift? Okay, so it's always inhibiting your moment because there's always that acetylcholine in your way. All right, always inhibitory. Doesn't matter where. For this system specifically, it's inhibitory to movement. Okay, then we have glutamate over here in black. Okay, it's the 3rd receptor type found on the putamen cells. And I put it in black because it both excites and inhibits movement. If we're in the direct pathway, it excites movement. If we're in the indirect pathway, it inhibits movement. And that's where we'll pick up next in the next Refrigerator YouTube video. Hello and welcome back. Now we're going to talk about the direct pathway of the basal ganglia. And just to recap, when I have something in green, it's because it's excitatory to movement, and when it's in red, it's inhibitory to movement. We are not talking about neurotransmitters with that. We are just talking in general. If something is green, it excites the movement, and if it's in red, it inhibits movement. And then we'll discuss the individual neurotransmitters as we get to them. All right, so let's get started. So I like to call the direct pathway directly to movement, because that's what it does. The direct pathway leads directly to an enhancement in movement, okay? So that is the overarching goal of this one. Okay, so how do we do this? All right, so let's start before we add in. Remember, we have our 3 players from the last video. We have our thalamus, we have our globus pallidus internus, and we have the putamen. That's our three players because this is the direct pathway. There's no that humbo mumbo jumbo with all the other nuclei that we'll get in the indirect. This is the direct pathway. So we have just those three players that we saw in the beginning for now. We'll add in a little bit more here in a second. So how does the directly to movement pathway work? Okay, so let's start off with just the cortex. Nothing else. We're just going to start off with the cortex and how it influences this pathway. Okay, so to start with the cortex comes down, it sends projections to the putamen, because remember we're starting in putting in bay. It all starts in putting in bay. We got to put our boat into bay. All right, so the cortex here is going to release glutamate on one of the receptors of those putamen cells. Okay, and you can see here that when glutamate binds, and in general, glutamate is an excitatory neurotransmitter. Now we're talking about neurotransmitters specifically. It is excitatory to that putamen cell. And that putamen cell then gets so excited, it goes ahead and it releases its neurotransmitter, which is GABA. And GABA in general is an inhibitory neurotransmitter. Again, talking about the neurotransmitter here. Okay? And then that transmitter gets sprinkled all over our globus pallidus internus. And that's good because, well, the globus pallidus internus, as we saw in the first video, it inhibits our thalamus. And remember, the thalamus, he's all about movement. He just wants to do movement. As you can see, he's got that big old green arrow up there. He wants to get the cortex going. He wants to get his movement. What the putamen does when it's activated from glutamate from the cortex is it releases its neurotransmitter GABA onto the globus pallidus internus. And so, essentially, it kind of just cancels it off. And now, the thalamus has its leash, so to speak, taken off of it, and it's ready to rup and roar, and it's ready to go out and excite movement. Okay? That's how that works. Now, let's see how dopamine influences this pathway. So, as always, we're talking about the neurotransmitter and the movement aspect differently. So here, we're going to have D1 cells. I'm sorry, not D1 cells, but D1 receptors. And you're like, well, you just pulled that out of nowhere. Not really. Look back up here at the directly to movement pathway. It's right here in the name, directly, D1. See it? D1. Boom. I like that. And remember, I kind of think of D1 as M1. You know, we're all excited. We're all ready to go, all excited to be in medical school. And that's the purpose of D1. It's excitatory. And this is beautiful. Look at this. So, remember, we got to start with our gas station, the substantia nigra pars compacta. It's going to produce our dopamine. Comes over here and binds to the D1 receptor. And that D1 receptor, to the D1 receptor, it's activating that putamen cell. Remember, we just talked about that putamen cell. That putamen cell releases GABA. And so when it gets excited from that dopamine, it goes ahead, it sprinkles out its GABA, and it inhibits the globus pallidus internus. And now, boom, we take the leash back off the thalamus, we go back up to the cortex, we get our movement going. Isn't that beautiful? I just think that's beautiful. All right, so now we've covered dopamine, we covered glutamate coming from the cortex. Now there's one other thing. So basically, there's one other thing. Before I was going to say that. There's one other thing now. We got our ass, acetylcholine. That's always in the way of our movement. Always the guy in the car in front of us slowing us down. So we got acetylcholine coming here from the interneurons located around the putamen. So you can just think about these little neurons around the putamen cells. And they're coming up and they're releasing acetylcholine, which binds to the putamen cell. What does it do to the putamen cell? It inhibits the putamen cell. It shuts down the putamen cell. And that means no GABA gets sprinkled. GABA's gone. So what's that mean? Globus pallidus internus has its way. It's inhibiting our thalamus, going up to our cortex. We're not going to get movement. Shuts down the movement system. All right, we'll continue next with the indirect pathway. Hello and welcome back to the refrigerator YouTube video on the basal ganglia. Let's finish up now by talking about the indirect pathway. And I love the indirect pathway because of its name. All right, the indirect pathway inhibits movement. That is the whole goal. And just remember, indirect, IN, inhibits, IN, movement. That is the entire goal of this pathway. And just keeping that in mind, that key concept that this whole pathway is going to inhibit movement, that is the basis to understanding it. Okay, so let's go down and we got to introduce two new players, okay? And remember, the whole theme of this pathway is to decrease movement. Okay, so let's start down here with the two new players, the globus pallidus externus, subthalamus, and the globus pallidus internus. Okay, for right now, ignore this right here. Just focus on the subthalamus and the globus pallidus internus, okay? So I like to think of the subthalamus is kind of the emergency brake. And I like to think of the globus pallidus internus as a brake. So imagine you're driving down your car, and then you hit the brake. That's the globus pallidus internus. It's stopping the movement. Okay? However, the subthalamus is like stopping, putting your foot on the brake, and boom, throwing in that emergency brake. You are really inhibiting movement. Okay? And you can see that here because the subthalamus releases glutamate onto the globus pallidus internus and really gets the globus pallidus internus going. So I like to think of the globus pallidus internus as a brake with your foot, and I like to think of the subthalamus as an emergency brake to really stop that car, to really stop that movement. Okay? So now, how does the globus pallidus externus fit into this picture? So let's focus right here. Well, the globus pallidus externus, as you'll see, is in green, which means it excites movement. Okay? So I like to think about the globus pallidus externus as externally removing that emergency brake. Okay? And it's in green because it excites movement and it removes the emergency brake, which is the subthalamus. And how does it do that? Well, how do you get rid of emergency brake? You take it off. And how does it do that? It uses GABA to inhibit the subthalamus, aka the emergency brake, allowing more movement. Okay? Alright, I hope that makes sense. Let's go back up and let's start down with our whole pathway. We're going to first look at how the cortex is involved, then acetylcholine, then dopamine to finish this out, okay? And then at the very end of this, we're going to have a nice overview of the pathways in kind of a succinct manner. Okay, let's start back up here with glutamate. So cortex, it releases glutamate, and remember, the whole pathway is inhibitory. It's inhibiting movement, okay? But we're going to look here at the individual neurotransmitter level, which is different, okay? So the cortex is going to release glutamate, okay? It's going to bind to the putamen cells. Okay? And glutamate by itself is an excitatory neurotransmitter. So it's going to get the putamen all excited, it's going to get it going, it's going to get the putamen all excited, and when the putamen's excited, remember, it's going to release GABA. Just like about every other neuron in this pathway. It's going to release GABA. And what is GABA? GABA is an inhibitory neuron. Okay? So what are we going to do with GABA? GABA is going to get sprinkled all over the globus pallidus externus. And it's going to basically take out that pathway. Okay? And why does that make sense? Well, remember, the globus pallidus internus is in green. It's promoting movement, and by inhibiting it, we are removing something that removes our emergency brake. So I like to think of this as just get rid of the globus pallidus externus, which is inhibiting our subthalamus. Remember, the subthalamus is emergency brake, so I like to think of the putamen coming online. It releases GABA, which gets rid of our globus pallidus externus and allows us to, wham, throw on that emergency brake with the subthalamus, which then releases glutamate onto the globus pallidus internus, wham, another brake, sprinkling all kinds of GABA all over the thalamus. Just sprinkling tons of it. We're not going to get any movement then. Okay? And that's the way I like to think of this pathway. Okay, now, in this pathway, if we're inhibiting movement, what neurotransmitter do you think is more important for inhibiting movement in this pathway? Dopamine or acetylcholine? Well, remember, acetylcholine's always been in red. It always inhibits movement, no matter the pathway. And dopamine's always in green. Remember, it's the gasoline that fuels our movement. Okay? So how does acetylcholine inhibit movement in the indirect pathway? Well, remember, acetylcholine is released by those interneurons, which surround the putamen, those cholinergic neurons, and they go ahead and they release acetylcholine, which is here in red. And what does that do? Well, if we want to inhibit movement, we really got to get the inhibitory pathway going. Okay? And how do we do that? We really get the putamen going. We really get it excited. So acetylcholine works in conjugation with the cortex and really gets the putamen going. The putamen releases even more massive amounts of GABA, and boom, we are really knocking out the globus pallidus externus, which is in green because it promotes movement. And by really releasing acetylcholine, it really allows the putamen to release GABA from the putamen, and it really knocks out this player, allowing the subthalamus, boom, that emergency brake to get thrown into place, and boom, it allows us to get the globus pallidus internus going, and boom, to take out the thalamus, therefore we don't get movement. Okay, now, we have one last player to get into this pathway, and that is dopamine, all right? So let me go here and erase some of this, all right? We're not as fancy as Boards and Beyond here, or maybe even Pathoma, but you know what? We do our best with our visual appearance, and so if I have to use a finger eraser, I have to use a finger eraser, just how it works. All right, so everything's in place. All right, now let's add back into that. Okay, so we've already talked about glutamate, we've talked about acetylcholine, let's add in dopamine, all right? And specifically when we're talking about dopamine, we have to be talking about the D2 receptor. Okay, and how do I remember the D2 receptor? which will be right here on this putamen cell. How do I know that that is the important receptor? Well, remember with direct, we had that many letters. With indirect, we added 2 more letters on. So I just like to think of D2 getting those 2 more letters in there. Okay? So that's how I think of it. And basically, now you really have to think about the physiology here. Because the D2 receptor, okay, it receives the neurotransmitter dopamine from the substantia nigra pars compacta. Remember, that's our gas station. It's going to release dopamine onto the D2 receptor. Okay, now this is where you really have to think about the physiology. What is our main goal of dopamine, no matter the pathway? It is to always get the movement going. It is always the fuel. The substantia nigra pars compacta is the gas station. Dopamine is the fuel. We got to get the pathway of movement going, of movement. Now, but let's think about this. We're in the indirect pathway, which inhibits movement. So, what do we have to do? We have to inhibit the indirect pathway. It's addition by subtraction. It's having negative influences in your life, and you're removing those negative influences. And how do we do that? These D2 receptors are inhibitory. Okay? And they basically knock the putamen offline. Get rid of that putamen. Okay? And this allows our new guy right here, the globus pallidus externus, he gets going, he increases in activity because we've removed that inhibition, and now he removes that emergency brake. Boom, we're going to sprinkle GABA down here on the subthalamus, get rid of the subthalamus, then we get rid of the amplification of the globus pallidus internus, and boom, we get more of the thalamus projecting to the cortex, exciting our cortex. And really, a bottom line of this is you can kind of think about it as, you know, once the D2 binds here, you can think about the D2 receptors basically leading to more activation or less inhibition of the globus pallidus externus, which allows the thalamus to increase its activity. And don't confuse this with a neuronal input to the thalamus. It's just to show you that these motor systems, the globus pallidus externus, increases movement as shown by the green. Okay? Isn't that beautiful? It's a complicated system, and you have to really think about the neurotransmitters. But I think if you keep these 2 big ideas in mind that we're going to review on the next bottom of this refrigerator, I think we'll be able to score quite well on this. All right, so let's move down to the bottom of the refrigerator. Look how much we've processed from in 1 year. Now we get to use even the bottom of it. All right, and my cat wanted to join the video. Hi, Penny. All right, so we got to start here with the direct, okay? So, I'm sorry, let's start with the indirect, all right? Okay, so when thinking about, we're just going to look at the direct, indirect, and these are basically, you can think of this as the neurotransmitter takeaway, okay? These are kind of the neurotransmitter takeaway from each of the pathways. So in the indirect, which we just saw up here, we saw that the cortex, when it releases glutamate, in conjunction with acetylcholine, ultimately leads to decreased movement. They both activate the indirect pathway, which inhibits movement. The converse is also true. The D2 receptor, when dopamine binds it, inhibits this pathway to increase movement. Okay? Now, in comparison to the direct pathway, okay, over here, the cortex released glutamate, and along with the D1 receptor with dopamine, increased movement, and acetylcholine inhibited this pathway to decrease movement. Okay? And basically, one other big takeaway is the D1 receptor in the direct pathway is excitatory, and it excites this pathway, which is all about movement, exciting movement. That's why it's in green. And the converse, the D2 receptor is inhibitory, and basically it's inhibiting the indirect pathway, which inhibits movement, therefore increasing movement. All right, y'all, it's been fun walking through this. I hope this helps. It's very complex. It takes a lot of time, and I wish us all the best of luck with it. All right, it's been fun. We'll see you in the next Refrigerator YouTube video.